If I go to I to the fifth, I can say that I to the fifth is I to the fourth times I. Now I to the fourth is 1, and 1 times I is I. So you see I'm starting all over again. In fact, every 4 cycles, I will start repeating itself. It goes through the cycle I, -1, -I, +1. So you can see the cycle, again, if you look at all of them, it's going to start with I, then it's going to -1, -I, +1, and then back to I. Well, let's jump ahead and see what I to the 22nd would be. Well, I want to break it into a power of something that is a multiple of 4. The reason I want a multiple of 4 is I to the 4th is 1. 20 is a multiple of 4, so I can write I to the 22nd as I to the 20th times I squared. Again, the reason I wanted to use 20 is a multiple of 4. Why did I want multiples of 4? I to the 4th is +1. So now I can write I to the 20th as I to the 4th raised to the 5th power. Because to raise a power to a power, you keep the base, multiply the exponents. Well, I to the 4th is 1. 1 to the 5th is 1. So I have 1 times -1. Because I squared is -1. And 1 times -1 is -1. So I to the 22nd is just -1. I'm going to put in a box the powers of I that you need to memorize. Once you memorize the basic 4, then you can use the multiples of 4 procedure I've just discussed to get into the rest of them. But you need to know I is -1. I is the square root of -1. I squared is -1. I cubed is -I. I to the 4th is 1. So you need to know your powers of I. Now we're ready to go to multiplication. Now recall what I gave you earlier. Before you can perform operations with complex numbers, you've got to put them in the standard I notation. So I cannot multiply this to start with. What I have to do is to write it using I notation. The square root of -9 is the same as the square root of 9 times the square root of -1. The square root of a -4 is the same as the square root of 4 times the square root of -1. The square root of 9 is 3. The square root of -1 is I. The square root of 4 is 2. The square root of -1 is I. So I have 3i times 2i. So now the numbers are in standard complex form. I can now multiply them just like you normally would. 3i times 2i is 6i squared. 3 times 2 is 6. I times I is I squared. But now you have to know that I squared is -1. So I have 6 times -1 or -6. So the correct answer is -6. Now if you had not put it in correct form first, you'd have the wrong answer. Because if you simply multiply -9 times -4 would be a +36. The square root of a +36 is 6 when you're using the radical notation. So in order to avoid any confusion, be sure that you write in complex form first. Let's look at a couple other examples. Let's look at 2 subtract 3i times 4 subtract I. Well, that particular problem was just begging you to use the full method on it. So that's what we're going to do. We're going to multiply the first two together, and that would be 8. Then I'm going to do the outside. That would be a negative 2i. Then I'm going to do the inside. And that would be a negative 12i. Then I'll do the last, which would be a positive 3i squared. Because a negative 3i times a negative I, negative times negative is positive. It's understood to be 1. 3 times 1 is 3. I times I is I squared. So we have 8 minus 14i plus 3i squared. But now, don't forget to substitute I squared by negative 1. So we have 8 minus 14i plus 3 times negative 1, because I squared is negative 1. So we have 8 minus 14i minus 3, which is 5 minus 14i. That looked like fun. Let's do another one. Let's do 12. Subtract 2 times the square root of negative 25 times 2 plus 3 times the square root of negative 9. Well, I do have to change the standard complex form first. So I can write this as 12 subtract 2 times the square root of 25 times the square root of negative 1 times 2 plus 3 times the square root of 9 times the square root of negative 1. Or I have 12 minus 2 times 5 times I. The square root of 25 is 5. The square root of negative 1 is I. Times 2 plus 3 times 3 times I. So I have 12 minus 10i. 2 times 5 is 10. Times 2 plus 9i. So now I have it in standard form. Once I have it in standard form, it's just like the last one. Using the FOR method, 12 times 2 is 24 plus 12 times 9 is 108, so it'll be 108i minus 20i, 2 times 10 is 20, minus 90i squared. Be 24. Now positive 108 minus 20 is going to be a plus 88i minus 90 times I squared is negative 1. So it'll be 24 plus 88i plus 90. 24 plus 90 is 114 plus 88i.